Have you ever observed a situation like this? There's a child, and a child holds a block or a toy in their hand. And at some point, they take the toy or a block and just throw it away. Sometimes we can observe parents reacting negatively to behaviors like this. And that's because some parents might interpret those behaviors as aggressive behaviors. And although this might be the case sometimes, it turns out that most of the time, children throw things like this because it helps them learn. It helps them learn how the physical world works. But that's only one way children learn. That's also one of the ways in which children's learning differs from how most machine learning systems learn.
What?
Alison Gopnik, American developmental psychologist, has demonstrated that children perform systematic experiments that allow them to learn the laws of physics and the rules of social interactions. Amy Stahl and Lisa Feigenson from Johns Hopkins University have shown in their research that infants as young as 11 months prefer to experiment with objects displaying unpredictable properties, like toys that can pass through walls, for example, rather than play with more predictable ones. Infants' ability to interact with the world not only makes their learning more robust compared to just observing the environment, but it also informs them which hypothesis to test next. This creates an interactive chain of hypotheses and tests that aim to falsify them. All of this, taken together, gives children a powerful toolkit for building effective world models. This capability makes infants, and later on children, different from most contemporary machine learning systems, which typically learn in a more static way. So, what are the consequences of learning in a static versus more active way? We'll discuss this in the next videos.